confident, and maybe sometimes I get lost in my mind and forget some things. But now we were told that our exam will be held online in Ortus system, so I think yeah, it's pretty good.
Last time it was through our online platform, yes, in order.
Yeah, midterm exam was through the online platform.
Okay. Okay, we will wait. I think how many? 5 minutes, okay? And after 5 minutes, we will stop.
Okay.
Mm-hmm. Yeah. Okay, let's start today's lecture. So, do you remember what we had talked in our last lecture? The topic, I mean.
The topic of our last lecture. Um, not sure. I do remember that we have passed something, but exactly. Um, our last lecture was 2 days ago, or oh wait, we passed multiprocessors, right?
Multiprocessors, yes.
Yeah, multiprocessors.
Okay.
And I mean the multiprocessors, the systems of multiprocessors. How? What are the benefits? I mean the pros and cons of multiprocessor systems. Um, and how do they work? How do they exchange data?
Okay. What does it mean multiprocessor?
Oh, well, multiprocessor from its own name, we can say that it's a like a system which has two or more processors, which uses two or more processors.
Okay.
Sorry.
Mm. So, in our previous lecture, we talked about the multiprocessor, yes, and we talked about the multi-computer architecture,
Yes.
yes, is right.
Multi-computer. Multi-computer. No, we haven't passed multi-computer yet. We passed the multiprocessors. That's for sure. Uh, the multi-computer
Yes,
we
the
haven't
topic
reached it.
was the multiprocessor systems, yes. But we also talked about multiprocessor operating system,
Yes.
multiprocessor system architecture.
Architecture. Yeah.
We
And
talked about the multiprocessing itself, yes. What does it
yes.
mean? Where we can use.
Yes.
So, any information do you know about the multiprocessor operating system?
Multiprocessor operating system. Well, I can say that a multiprocessor operating system
Mm-hmm.
is like a system which uses more than two or more processors. I mean, two or more processors. How's it called? Central processing units in a computer system. I mean, in one computer, there can be two or more processors, which
Mm-hmm.
are connected to each other. And I mean, they share information to communicate using buses,
Mm-hmm.
memories, and and also maybe peripheral devices.
Okay. So, thank you. Like, what I want to say is, here we talked about the also the benefits and the drawbacks of the multiprocessing. Yes.
Yes.
Uh, could you give me some feature, some could you give me the list of the benefits?
The benefits. So the advantages of the multiprocessor systems is that the multiprocessor system doesn't need much. Well, we can say if we are talking about if we're having one multiprocessor system computer,
Mm-hmm.
then it doesn't take much space. I mean, it's all in one computer system. We don't have to use multiple computers.
Mm-hmm.
And Obviously, using more than one processor is always a big push in the the execution of the program. I mean, the time that the program executes, it goes more quickly. And mm, Multi-processors, if we're talking about like considerations, maybe as I remember, they're more complex in the sphere of hardware and software, so it's like a little bit difficult to realize a multiprocessor system. But
Mm-hmm.
if we do, it will work. So um, and sometimes additional when the
Mm-hmm.
processor executes some kind of operation, I mean, instruction or the data that the user has entered, it might need to cooperate with the other processor one more cycle, time cycle, which obviously makes the efficiency of each processor go down, but not in overall. So if before we used, let's say, how, I don't know how to measure it, maybe 100% speed working processor, and we connected one more of 100% speed working processor, and we gave some instruction operations to the processor so it will execute it. And while it executes, it makes the efficiency go down. So it means now both of the processors individually work for 90%, maybe 80%, but overall it's still faster.
Mm-hmm. Okay.
So yeah, and reliability, oh, sorry, was it
Reliab-
reliability?
yes.
Reliability. Yeah.
Uh-huh. Good. Very good. Good job. So then also let's talk about the types of the multiprocessor operating system. Like, so we have discussed it, 6 types of multiprocessor operating system. Yes.
Yes.
What are they? They are the symmetric multiprocessor. They are asymmetric shared memory multiprocessor, distributed UMA and UMA multiprocessor system. Yes.
Yes.
And you know about the shared memory, yes? I think I
Yes. We
have
have passed
explained
it.
to you.
Yes.
Mhm. So, okay, I gave you the definition for the symmetric multiprocessor. What does mean symmetric multiprocessor? Yes,
Yes.
asymmetric. Also, we have discussed it.
Yes.
And
This is like mostly. I'm sorry to interrupt you. It's mostly like processor networking with
mm-hmm,
data, like how they communicate with each other.
mm-hmm, yes,
Okay.
yes. Then we give the explanation for the shared memory multiprocessor, distributed UMA and NUMA. Sorry, NUMA. Yes. So
Yes.
here, um, then we talked about the benefits of the multiprocessor operating system. Yes.
Yes.
So as you said, yes, reliability and throughput. We have in throughput. We have advantages in terms of cost effective and parallel processing. And we have so many disadvantages. We have also discussed this part and some feature of the multiprocessor operating system. Then next is what we yes, multiprocessing itself. What does it mean? So it's all about the like a multiprocessing system. But
Yeah.
today, our topic is also closely like how to say it, not similar, but in terms of the meaning, it is closer to previous lecture. So today we will talk multi-computers.
Okay.
Okay. So our topic is multi-computers. And our plan for today is we will talk the concept of multi-computers. What does it mean? And we will talk difference between the multiprocessor and a multi-computer. So let's talk about the multi-computers. So the system uh, with the multiple processors that are connected together to solve a problem called multi-computer system. Yes. Here, each processor has its own memory and it's accessible by a particular processor, and this processor can communicate with each other through interconnection network. When you see the picture of the multi-computers, the architecture of the architecture of the multi-computers. Here we can see interconnection. Yes, we have several CPU, and the CPU is connected through interconnection. Like uh, we have central component, and this throughout central component we can go to the next other parts. So all of these components, the purpose of these you I mean the purpose of using all of these components is to solve the given the problem. Okay, therefore we need such kind of architecture.
Okay.
Then let's talk about the further. Here we can see multi-computer is also has capability to message passing between the processor, and it's possible to divide the task between the processor in order to complete the task. So we can send a message between the processor, and if you have a task, you can divide the tasks between the processor. So also here we can see that multi-computer can be used for distributed computing, and it's cost effective, which means that it's like cheaper and easy. It's easy to build multi-computer than multiprocessor. See here, do you know about the multiprocessor that we have discussed it in our previous lecture? So what I want to say is, if we want to build a multi-computer, it's easier in terms of the cost when you compare with the cost of the building of multiprocessor here. So I think we can differentiate, yes, the word itself, multi-computer and multiprocessor.
Yes.
Then let's talk about the difference between the multiprocessor and multi-computer. So, okay, could you give me some opinion about this? The difference between the multi-computers and multiprocessor?
Yes. Well, as we passed the lesson before, that a multiprocessor is a system of two or more processors that are connected with each other symmetrically. So it means that they don't have this, how is it called, slave and mastery, as I remember. So they are equal, and they communicate with each other only, and sharing, they decide on what operator or operation they are doing. But if we're talking about a multi-computer is a system which uses also two or more processors that are controlled by a computer. I mean, by let's say, I don't know how to call this, like it's just controlled by a computer. Like they, if we're, I can compare it with networking, like the networking of, let's say, an office. There is a server where all the computers are connected to, and the server, if a user wants to send some kind of data to another user, he sends it to the server, and the server sends it back to the user that was the data was addressed to. So here's similar. So the CPUs, they can't directly communicate with each other. They can communicate through control unit. Let's name it like this. So it's a computer. Multi-computer is a computer with two processors that are controlled by control unit or some kind of uh, well, they are just not connected to each other directly. They can't communicate with each other directly. They have to do it through um, some kind of, I don't know, chip. I'm sorry. I think someone's knocking at the door. I'm gonna open it.
Okay,
Just a
okay.
moment. Send it towards my neighbors upstairs. Thank you.
So here, when we talk about the multiprocessor, yes, the multiprocessor is the system which has 2 or more central processing units. But when we talk about the multi-computers, here, the system is where computer system with the multiple processors that are connected together to solve a problem. So the difference here, like
they are not connected to each other directly. They're
yes,
using an interconnection.
yes, yes. But multiprocessor, I think we don't have any interconnection. Yes.
Yeah, only buses that are connected to each of the processor.
So then, when we talk about the multiprocessor, we have to talk about the capability. Yes, so capable of performing multiple tasks, where multi-computer is a system with the multiple processors which are attached through interconnection network in order to perform a computation the task. But when you talk about the we have another like opinion here. See, multiprocessor system is a single computer that operates with multiple CPU, where as a multi-computer system as a cluster of computers that operates as a singular computer. Yeah, when you talk about multi-computer, we have a bunch, combination of the computers which operate as a one big computer. Multi-computer, many computer, multi-processor, many processors.
It's simple.
Okay, and then when we talk the difference, another difference is in terms of construction and in terms of the cost. Yes, we can see that the construction of multi-computers is easier and cost-effective rather than the multiprocessor. Yes, a multiprocessor system program tends to be easier, whereas in a multi-computer system program tends to be more difficult. Then multiprocessor supports parallel computing, yes, but multi-computer gives you distributed computing. Okay, so further, let's talk about the difference again. But before talking about the difference, I want to give you the video. Let me open the video. The video is about how the CPU use multiple core. Okay. So in this video, you can aware how the CPU use a multiple core.
Okay, well maybe 6 cores, 8 cores, 6 cores, 8 cores, 40 cores. Okay, well maybe not the last one, but high CPU core counts are a major selling point for computers and even other electronics these days, whether you're shopping online or talking to a worker bee at your local big box store. And the idea behind it is simple. Higher core counts suggest more power, kind of like impressive looking horsepower numbers on a car. But is this always the case? Well, if you, like many Tech Quickie viewers, are a PC gamer, you've probably seen advice around the web or from friends that super high-end CPUs with many cores or hyper-threading on something like a Core i7 won't help you much, if at all, in games. But why is that? With the demand that current titles put on the hardware, why are people averse to spending more on a more powerful CPU? Well, the answer lies in a concept called parallelization, which means splitting a program's workload across multiple processing cores so a computer can work on two different parts of the same load at the same time. For example, let's say you want to know what 5 times 4 times 3 times 2 is. A single core CPU would first multiply 5 times 4 to get 20, then multiply that times 3 to get 60, and so on and so forth. However, a dual core CPU could assign 5 times 4 to one core and 3 times 2 to the other, solve both problems at the same time, and multiply the results together, effectively saving time. Since it doesn't matter what order you execute the instructions in, since you're just telling the CPU to multiply numbers, this math problem is easy to parallelize. Now, although this is a painfully simple example, it does illustrate how certain programs can take advantage of multiple CPU cores because they require lots of number crunching that can be easily split up. Applications for video editing, encryption, file compression, and even scientific research such as weather modeling do lots of calculations that can be parallelized easily. Also, computer GPUs are designed for parallel computing, since the same idea holds true for rendering 3D graphics in a game. So you can learn more about that in this video. But Linus, if my graphics card is designed for parallel processing, why shouldn't I also be getting a CPU with tons of cores? Well, the thing is that your GPU often doesn't handle much else other than pushing out frames to your monitor. Other important aspects of games, such as artificial intelligence, responding to inputs, and telling the GPU what to render, are still handled by the CPU. Because of the complexity involved in processing things like AI and other forms of game logic, and the fact that many of these code instructions for these types of things must be done in a specific order or in reaction to the gamer, they're much harder for programmers to parallelize and split the workload, especially as many current game engines aren't designed from the ground up to take advantage of multiple cores. That said though, your mileage may vary depending on what game you're playing. Some games, due to variations in the processes the CPU is handling, are more CPU bound than others and can benefit slightly from additional cores. And since getting games to take advantage of lots of cores is a bit of an unsolved problem in the industry, work is ongoing to try to figure out how to make higher-end games easier to parallelize, which could ultimately result in cooler, more immersive experiences. But for now, if you're just using your PC to game, getting anything above, I'd say about a 4-core, is probably overkill, and you're better off focusing your resources on, well, getting cores that perform well individually for one thing, and on other components of your system. Speaking of individual performance, do you wish your internet connection could perform better? Well, TunnelBear VPN is not the solution to that. No, a VPN does not make your internet faster, but what it does do is it makes it so that you can tunnel your internet to a different country, up to 20 different ones with TunnelBear, and use online services and websites as though you are browsing from that country. They've got easy to use apps for iOS, Android, PC, and Mac, as well as a Chrome extension, and it is as simple as choosing the country that you want to be browsing from. You know, like let's say there's a content block on browsers from a particular region, and you're like, oh, I want to see that stuff. Boom! You click the button, TunnelBear encrypts your connection and makes it appear to all those services and websites as though you are browsing from a completely different place. And they take all the nonsense out of it. There's no port forwarding or DNS configuration or anything like that, and they've got a top-rated privacy policy too. The best part though is you can try TunnelBear VPN with 500 megabytes of free data per month, no credit card required, for free at the link in the video description. And if you decide to upgrade to an unlimited data account, you can actually save 10% at tunnelbear.com/Linus. So thanks for watching, guys. If you liked it, liked it. If you disliked it, dislike it. If you want to check out our other channels, boom, boom, cool video on Channel Super Fun right here. Leave a comment if you have suggestions.
So I hope you understand the concept.
Yes, it was really clear when you explained. I mean, like that. It's also if you think like logically, if a computer has more processors and let's say a multi-processing system, it means that it can do multiple tasks at the same time or divide the amount of calculations on each processor, which will obviously make it faster.
Yes. Okay, we were talking about the difference between the multiprocessor and multi-computers, yes. So
Yes.
here we have to continue about the difference. The general purpose parallel or distributed computer system can be also divided into two types, two categories, multiprocessors and multi-computers. The main difference here, the two types lies in the way in which communication between the processor is organized. See, so here the communication between the processors is organized. It's the main difference. Keep in mind here, like it's one of the main difference between the two categories.
It's with the connection that one is parallel connection and the other is like after each other.
Yes.
Okay, got it.
Yeah. Also, all the processors share the same memory. Same memory space in multiprocessor system, while in multi-computer system, each processor has its own private memory space. There must be explicit communication interface between the processors inside the multi-computer system, but this implies that there is a higher latency of communication between processors than will be the case if direct memory access was possible. When you see the picture here, we have the memory, we have the network, and here we have the components. The components connected to the memory through our interconnection network, yes. But here, we don't have any memory, but we have memory each component. See?
Yes.
The logic is like this.
So like
I think here is first one is multi-processor, second
yeah,
one
it
is
is.
multi-computer.
Yes, but also in the first one, I don't know why there is not shown the bus lines of the. I mean, like a multiprocessor system is a system that completes multiple tasks at the same time, but a computer system is a system that completes one task, but each calculation is divided into all the processors. So
Yes.
that's why I think it needs its own memories down there, like where it stores its own memories.
That multiprocessor system can be subdivided into tightly coupled and loosely coupled system. A tightly coupled system has common main memory, so the access time from any processor to memory is the same. And in a loosely coupled system, the main memory is distributed among the processors. Yes. Also, the processors share the same memory space. A processor can address another part of the main memory, but the access time is higher when you compare to accessing the local part of the main memory. Then finally, the partition and allocation of the program segments and data play crucial role in the design. There are also several ways to map. Map means here join the to map the basic operations onto the processors. The simplest choice is generalizes the processor type that can execute all types of operations. Architectures of this type are called homogeneous architectures. This choice simplifies processor assignment since each operation can be mapped onto any of the free processors. So another choice is to use dedicated processors, which can execute only one or a few types of operations. The performance of these processors can be optimized with respect to their functions, but they may be poorly utilized if they are too specialized, with the workload for each type becoming a lot. So design problem is to find the number of feasible implementations points in the research time domain by proper scheduling and by using alternate processor type. So it's all about the difference between multiprocessors and multi-computers, okay?
Okay.
But now, before talking about the generation, let's look at some video about the CPU multi-user setup. The video called, the topic of the video is CPU user setup.
Okay.
The reason here, I couldn't find the video which closely related to the topic, but in the video you can find the concept which is closely related to today's topic. And today we will talk not only about the multi-computers, because the information is about the multi-computers is few, like we have less amount of the information. But today we will talk about the another topic. Okay, you will see when we finish about the multi-computers.
Okay.
Face this. Almost every one of us might have faced this. It is not possible to have PC for everyone always. And it's not always easy to share one PC with multiple person. So there was an idea to have multiple workplaces from single CPU. It can save some amount while setting up your business. Also, you can call your friends to home for a multiplayer game session. While there are many more applications to this idea, but doing this sometimes need extra hardware. There are some software solution to home use or many business setups. One of the popular idea was to set up a virtual machine in second window. But as we know, running multiple OS really harms your performance. So the better solution is to access one OS by multiple users. There are only few softwares in market, but one of them we recommend is Aster version 2.18 by IBIC. Let's check out this software on their website. As we can see there, Aster supports Windows XP, Windows 7, Windows 8 and Windows 10 as well. It's compatible with almost a long range of video cards. Some USB hubs are needed to plug in all your hardware. And you may need video output ports accordingly for your monitors. You may learn more from their website www.ibic.ru. Check out the link at the video description. From their download page, download the latest version of Aster. For Windows XP, please download the different version provided at the page. The setup process of this software is very simple. Just run the setup, select language. Then in the installation first page, please check the Create Restore Point option. Better safe than sorry, right? Press next and give it a minute to create a restore point for your system. In the next page you can read all the information regarding Aster. Also, there is a link for the user's manual there. Press next. Agree with the terms and condition. Wait, have you read it? Just asking, you know. On the next screen, setup installation folder and all. If you are using Windows 8 or Windows 10 rather than Windows 7, then most leave the disable fast boot option checked. Wait for the installation to finish. Oh no. Give your system a little time to reboot. After reboot, Aster interface will automatically come up. Make sure you are connected to internet. Press OK, then note down the installation ID for future reference. Then click OK to update and restart the Aster. On the very next start, Aster will ask you for the registration process. If you already bought, then activate the license, or if you want to try first, then just click to activate a 30 days trial period. Give it a while, and after activation the main Aster window will come up. We personally say that this software has a very easy and user-friendly interface. On the general setting, turn on the number of workplace you want to run under state. After setting up, you can enable Aster with a reboot. On the Workplace tab, all the enabled workplaces are shown. Here you can assign specific hardware to specific workplaces. Plug in all your devices. Then drag and drop the devices as your need. It is really easy. You can read device name by hovering mouse on the devices, or you can just simply press some keys on keyboard or on mouse. A blue indicator will help you to recognize which one is where. Also, if you plug in some new hardware, then you can see a pink indicator too. The background of a workplace will be green when it has at least one monitor, one mouse and one keyboard. In Extended Setting tab, you can set up the local network between your workplaces. And at the end, the About page. Also, there are some advanced settings. In General Setting, every workplace is set to show the login screen, where user can select the user they want to log in, or you may set it to use specific user account directly. Then enable and reboot the system again. Now on reboot, your workplaces will be ready. You can now log into different users of your system from different workplaces. Run the Aster control panel from the workplace which has been logged in with your system administrator account. In the Aster interface, you can see that it is activated and running now. In the Workplaces tab, you can check your devices. You can also provide dedicated mic and speakers to individual workplaces. The devices under share will be used by every workplaces. If you have extra devices, then you can drop them in spares section, then they will not be used by any system. After you finish customizing, click on Apply, then close the window. Now you can have multiple users from a single PC. This was a basic process for setting up Aster version 2.18. You can learn more from their user manual. You can also download and buy Aster from the link provided at the video description. Please like this video if this helps. Dislike if you don't. Subscribe us for future updates. Almost.
Okay. Hope you understand the concept. Now we have to talk about this regeneration of the multi-computers here. The first is the design choices in the past. Yes, while selecting processor technology, multi-computer designer choose low-cost medium grain processors as building blocks. Majority of parallel computers are built with standard off-the-shelf microprocessors, and this is bit memory was chosen for multi-computers rather than using shared memory, so which would limit the scalability. Each processor has its own local memory unit. For interconnections, multi-computers have message passing point-to-point direct networks rather than address switching networks. For control strategy, designers of multi-computers choose the asynchronous MIMD, MPMD, and SMPD. So then we have the present and future development. It's the second generation. The next generation computers evolved from the medium to fine grain multi-computers, which use globally shared virtual memory. So second generation multi-computers are still in use at present. So we can see the second generation multi-computers, but using better processor like i386 and 860 and so on. The second generation computers have developed a lot. So we can see the difference between the first and second. The second generation multi-computers are more developed. What about the third generation? The third generation computers are the next generation computers where we uh, VLSI implemented nodes will be used. Please note here, VLSI is, I think, very large scale integrated. Each node may have 14 MIPC processor and 20 megabytes per second routing channel and 16 kilobytes of RAM integrated on a single chip. So the last is Intel Paragon system. So previously, the homogeneous nodes were used to make hyper-hub multi-computers, as all the functions were given to the host. Yes, so this limited the I/O bandwidth. This, therefore, to solve large-scale problems efficiently or with high throughput, these computers couldn't be used. The Intel Paragon system was designed to overcome this difficulty. It turned the multi-computer into application server with multi-user access in a network environment. It's all about today's topic. Do you have any question about the
No questions. It was clear. It wasn't a very hard topic, since it was also related to the multiprocessor and all the topics that we have passed before. They are like they are similar to this.
So here, if you don't have any question about the multi-computers, so let's talk about the another topic, like, which is related also multiprocessor, multi-computer systems.
Okay.
The topic is multi-core computer architecture. So we have some, like, how to say, plan. Let's say, like, I have every time I have a plan for the lesson. So here also I also divide into this, like, category. So we have introduction, multi-core organization types, how multi-core works, and benefits and drawbacks, which is advantages and disadvantages. So feature of multi-core processor, and we will conclude. We will make a conclusion.
Okay.
So let's talk about the concept here. The use of multiple processor on the same chip, which is called multi-core. So if you use the multiple processor within the same chip, so it's called multi-core. So it provides you chance to increase the performance without increasing clock rate. Okay. Then when processor has more than one core to execute all the three functions of a computer, or you can say a chip with more than one CPU. Okay. Then multi-core computers. Let's talk about the architecture. So here, multi-core processor implement multiprocessing in a single physical package.
Okay, got it. So like these cores are later implemented inside the processor itself, so it makes like a multi-core processor.
Yes, like
Okay.
a multi-core processor implements multiprocessing, which means that it uses the multiprocessing in a single physical package. Also, it has possibility of parallel computing. Then this reduces the system's heat and power consumption, which helps us to reduce the system's heat and power consumption. Okay.
Okay.
So multi-core processors are widely used across many application domains. For example, general purpose, embedded, network, digital signal processing, and graphics. So Could you give me some example if for example, if you noted during your life, example for, let's say, multi-core processors?
Multi-core processors. Multi-core processor. I think my computer has a multi-core processor. Has, if I'm not wrong, 6 cores.
Mm-hmm.
And as I know that the cores in the processor, well, as you explained, they work as a multi-processor system,
Mm-hmm.
which makes it faster. I mean, the computer faster by, executing any programs or some kind of doing some kind of operations. Everything goes faster. And about the cores, multi cores. Like what kind of example? Um, I'm sure that the multi-core processor, it can run one instruction on separate cores at the same time. So as I said before, it increases the efficiency of the processor itself if it has some cores. Um, yeah, so like I'm not sure about the graphics card. If it, oh, I know that the graphics card has a processor also, but I'm not sure if it has cores because I know that it has some kind of virtual memory, which isn't RAM. It's some kind of different memory. But about if it has some kind of multi-core processor, I'm not sure.
So what do you think about the smartphones? So
All right. Yeah,
do
they
you feel
surely
like,
have.
in the smartphone we have a multi-core architecture or something similar to multi-processing or multi-computers?
Well, since we can play games with our phone, I think yes, it surely has a multi-core processor, and I also think it has some kind of processor that is um, related to visual. I'm sorry, my dog distracted me. I forgot what I wanted to say. Uh, well, I think yes. I just think yes that our phones have multi-core processors.
Mm-hmm. Okay. So I think when you open the program, yes, at the same time you can run, you can open several programs, several apps. So in this case, maybe in order to run the multiple program, you need to have multi-processing system which runs and hold the like several apps, several programs at the same time. Because uh, just imagine you open 5 programs here, for example, Google Chrome, let's say your game, let's say you open it also video, yes, but and then other 2 programs, I don't know. Then just imagine at the same time the 5 program is working, but you saw you are playing game, but another 4 program open. You didn't you didn't close it, but suddenly you switch another program. For example, you suddenly want to watch the video. Yes. Here also the multi-processing system or multiprocessor we have uh, implemented, because um, several programs runs at the same time simultaneously.
Got it.
So here, what do you think about what does a multi-core processor do?
Well, as I said, it works. Well, it was also written before that a multi-core processor is uses its cores to do some kind of instruction, give some kind of instruction that it receives to each core, so it will execute it, and it works. The cores work as a multi-processor system, so it can execute multiple tasks at once at the same time.
Yes. Also, it takes also advantages of multiple cores at once, yes. And multiple things, multiple programs to be done at once, which is easier to finish the task. So here, can you please, I highly recommend you to pay attention. We have 4 pictures. The picture 1, dedicated L1 cache. Picture 2, dedicated L2 cache. The third one, shared L2 cache. Yes. And the last one, shared L3 cache. Yes. So as you can see here, we have CPU core 1, core 3, as core 2, core 3, and a lot of CPU core. And we have L1 and L1. Yes. We have L2 cache and input-output devices and main memory. So this 4 picture gives you explanation how the architecture is localized into category of the 4 types. Here we have 4 types of architecture. How the multi-core is designed. So here we don't have L2 cache. Only in picture A, we see we have 3 components outside of this main block, but others looks like the same.
I got it.
The C and D, the L2 cache is situated inside the block.
Yeah, it's inside the block, and it's like one whole. It's not divided into 2 when it's if we compare it to the dedicated cache.
Yes, yes. So here, about the organization. So number of core processor on the chip, the number of levels of the cache memory we have. We're talking about the multi-core organization here. The number of core processor on the chip we have, the number of levels of the cache memory, and amount of the cache memory that is shared. Okay.
Yeah, got it.
So here the big picture for Core i3, Core i5, and Core i7.
In different generations.
Yes, the last generation is 8 years.
8. I think even 9. I'm not sure.
9.
Let me check. Latest generation of Intel processors. It's 10th generation.
But in our market, you cannot find the 9th generation.
If you even find it, it will be like twice as expensive.
Yes, yes.
Just a moment. My dog is too loud. I can't do anything. Sorry.
Okay, let's talk about the feature of the, like a different feature of the Core i3, Core i5, and Core i7.
Okay.
Here, see, we have 2 cores in Core i3. We have from the 2 to 4 cores in Core i5, but we have 4 cores in Core i7. And the Core i3, when you compare the 3 architecture, we have high-burst reading in Core i3. We have turbo boost technology in Core i5, we have both hyper-threading, turbo-based technology combined, yes, in the Core i7. See how this Core i7 is strong. And we have the 3 to 4 megabyte in Core i3, which is, I don't know what is it. I forgot, sorry.
Which one?
The last one, 3 to 4.
I think it is maybe I'm not sure. The cache maybe inside.
Yes. And 6 megabyte in Core i5, but 6 megabyte plus, which is, it means that more than 6 megabyte in Core i7.
Yeah.
Yes. So let's talk about further. Here we see the example for the cores. So thread is simple, single stream of data from programs throughout the processor on the PC. Yes. Thread is a kind of channel. So with multitasking, single core processor can only handle a single thread at a time. So the system rapidly switches between the threads to process the data in seemingly concrete manner. The advantages of having multiple cores is that the system can handle more than one thread. Each core can handle a separate stream of data. The good processing speed of the multi-core processor is due to multiple cores which operate simultaneously on instructions at a lower frequency than a single core. Yes. At the same clock frequency, the multi-core processor will process more data than single-core processor. So multi-core processors deliver high performance and handle complex tasks at comparatively lower energy or lower power as compared with a single core. So what application benefits from multi-core? The application benefits is database servers, web servers, compilers, multimedia applications, scientific application, and in general application with street level parallelism, or as an opposite to instruction level parallelism. So it's a benefits from multi-core. How
Okay,
many?
got it.
1, 2, 3, 4, 5, 6.
It's the applications
Mm-hmm.
that get benefit from it, not the benefits of the multi-core.
Yes. So but still we have some problem. See, we have power and temperature issue. We have it uses and consume a lot of power, and because of this, it I think generates more temperature. The level of parallelism in the application or algorithms. So we have parallelism in application and or algorithms, and we have interconnect problem. Yes.
Yep.
Okay. Let's imagine the feature of multi-core processors. So it's increasing the number of transistors per square millimeter of silicon, increasing the number of core in processor in efficient manner. Sorry, it's a mistake. And better materials for the production of processor to reduce the cost, and a more environmentally friendly production methods, and better software to improve the process of threading. And adding multiple cores within the processor gave the solution of running at lower frequencies. And multi-core processors are architected to adhere to reasonable power consumption, heat dissipation, and cache coherence protocols. So do you see here last version of multi-core processors? We have Core i9. I don't know
Okay.
which series. So it's all about the multi-core processor. So do you have any question?
No questions. Everything is clear.
Okay, so since you don't have any question, so I think your Next lesson will be the day after tomorrow.
Yeah, that's Sunday.
Yes, but the time I will announce, okay? I will write to the group.
Okay.
Okay, thank you very much.
Okay, thank you.
Have a
Have a
nice
nice
day.
evening. Yep. Bye.
Bye.